Hi, this is a related rate problem. So this problem says find, it says the volume of a sphere. They give us the volume, which is V equals 4 pi r cubed over 3. So the volume of sphere is decreasing at a rate of 35 cubic centimeters per minute. So the question is, how fast is the radius decreasing when the radius is 45 centimeters? So, so with this problem, we're going to, the first thing to do is to write down what we know. So what we know is that we know the volume of a sphere, which is V equals 4 pi over 3 times r to the third. And what else? We know the rate of change of the volume with respect to time is decreasing. Okay, so it says here the volume of a sphere is decreasing at a rate. So that's the rate of change of the volume per second, per minute. It's decreasing at 35 cubic centimeters every minute. So in terms of mathematics, we're going to call it dV/dt, which basically means the rate of change of the volume with respect to time, t. Is negative 35 because the decrease, when the rate is decreasing, basically when you write it down, you put negative. So the rate is negative. So then we are asked to find the change in radius with respect to time. And again, when the radius is 45 centimeters. So the first thing we're going to do here is to start with the connector. So when you read the problem, you'll see they give us the volume and the radius. They explain the change in the volume. They're also asking for the change in radius. So there's two variables. You have the volume and the radius. So what you need to do first, part of the solution, is to connect the two variables. So we're going to connect, they already give us the connector, the equation that connects the volume with the radius. So that is V equals 4 pi over 3 times r to the third. Now to generate the rate of change here from the equation, we're going to take the derivative with respect to t of the given equation. So what we say is we write d dt. We apply d dt to both sides of the equation of the volume. So when we d dt v, we get dv dt. And then you go and the d dt r to the third. When I say r to the third, because 4 pi over 3 is a constant, you just apply the derivative to the r cubed terms. So you're going to use what we call the power rule followed by the chain rule. Okay, so you're going to, when you take r cubed, d dt of r to the third is 3r squared. That's the power rule. Chain rule says to take the derivative of the inside function. So that's why you have a dr dt. And so then they gave us the change in volume, which is a negative 35. So we can replace dv dt by negative 35. And then from this equation, we will solve it for dr dt because we need to find the rate of change of the radius per time. So what happened here is that we simplify 3, and then we divide both sides of this equation by 4 pi times 45 square, because what we did was we plug in r, because r is 45, it's given to us, okay, and then we solve for dr dt, and we use a calculator to get dr dt is about negative 0.001375. So we say that the radius is decreasing at the rate of 0.001375 centimeters every minute. Because when you say decrease, that's basically decreasing basically means it's negative. So when you write this down, you don't put negative. when you have just have to state decreasing. Okay, so that's a related rate problem. And so we go to a second problem here is the related rate is that oil spilled from some kind of rupture of a tank or tanker. Um, so then the oil is spilling at as it's a circle of a circle which is the area of a circle is a equals pi r square, and as it's spilling, so that the rate that circle is increasing at a constant rate of 12 square miles every hours. Okay. So then it says how rapidly is the radius of the spill increasing when the area is 7 square miles. Again, when you read the problem, you see what they give us first is the connector, the equation that connects the area and the radius. So I equals pi r squared. And then they said they give us a dAdt, the change in the area per time, okay, which is it's a 12 square. So every hour there's a change of 12 square miles every hour. So that's how the oil is spreading. So we write this down, the dAdt, and then they ask us from here. It says find the change in radius. So basically we know it's dr dt when the area is a 7 square miles. Okay, when the area is 7 square miles. So we start with the connector, a equals pi times r squared. We're going to take the derivative respect to t of the equation, both sides. So on the left side we get a dA dt. On the right side, because pi is a constant, we can just apply the derivative to r squared, which give us 2r times dr dt. Okay. So we kind of rearrange it to get 2 pi r dr dt. Now we since they did not give us r, they give us dA dt. They did not give us r. They give us instead the area. So we can use the equation the area to find r. So the area they give us is 7 miles square miles, but we know the area of a circle is a equals pi times r square. So since a is 7, so from here we can solve for r to get r equals square root of 7 over pi. Remember, r is a positive quantity, so we get positive r. So now that we have r, we can go back to this equation and plug in all the givens. We know dA dt is 12. R, we just got it to be square root of 7 over pi. And then we can solve for dr dt. Okay, so for dr dt, you got, basically you multiply both, you simplify 2. Then you multiply both sides by square root of pi to get 6 times square root of pi over pi times square root of 7. We use a calculator to estimate this in 3 decimal places to be 1.279 miles per hour. Okay, that's how the radius is increasing. Thank you.